So the question was, just so it's recorded properly, what do you think about Enceladus, which is a moon of Saturn that is also an ocean world, and also a potential abode of life? It is the next, so let's say this, right now the field is pretty evenly split about which one's better. Let me say this, the Cassini mission, which was the previous mission, provided all of the information that Europa Clipper will provide, has already provided all the information we need for an orbiter. We do not need to send another orbiter to Enceladus. The next step for exploring Enceladus is something that can land on the surface and sample it directly. Europa is not there yet. Europa, we need to do all of the recon to see if there's places we can see for life. So right now, Europa is behind Enceladus, but the problem is building a lander is a lot harder than building something in an orbiter. So I think the next thing will probably be, so the next lander will probably go to Enceladus. Yeah. But I'm not in charge of that.
Why are some of the lines, like some parts of the lines, red, blue, and white?
Good question. So what those colors are representing is how high above the surface we are. So as you get, at least that's what I'm pretty sure it represents in this place. So we're flying by Europa, and as you get closer, the color goes from white to blue, and in a few cases it goes to red. Those are really low altitude flybys where we get really close. You might say, why don't you want to be close on all of them? Different instruments want different things. If you want to sample the material just above the surface, you want to get as close as you can. If you're trying to take pictures, realize the closer you are, the faster you're moving relative to what you're looking at. It can be much harder to get good remote sensing data if we get closer. And so we have an array of different values, which was based on all of the different people on the team arguing about exactly what was the best configuration for achieving all of the science goals. And I'm not going to pretend I knew all of those arguments for each particular thing.
Is Europa tidally locked?
It is. Yep. So it is a tidally locked body, which means just like Earth's moon, just so people know what the lingo means, just like Earth, we always see the same side of the moon facing us. You know, there's a near side and a far side. Europa, same thing. There's a side of Europa that always faces Jupiter. There's a side that always faces away. And that is the nature of Europa as well. That makes predicting these sorts of things a lot easier.
How much water is on Europa?
So different people argue about that. The ballpark estimate I said was roughly 2 times the amount of water in Earth's oceans. If you want that in kilograms or cubic meters, I'm not going to do that. But it's the thing is, remember, this thing is the size of the moon and has more, and if that number is right, more liquid water than all of Earth's oceans. That's why this is an ocean world. It's a lot.
How do you know that the Clipper isn't going to go too close to Jupiter and accidentally fly into it with the pole?
So that is a good question. Let's back up. So that is unlikely to happen because we try not to get too close to Jupiter. So there is a whole job, it's called an astrodynamicist. There are people who are paid by JPL, and for JPL for things like this, but they get paid by other people with doing satellites. All of this trajectory is so let's say this, the spacecraft has thrusters. Those allow it to change its trajectory a bit, But most of these trajectory changes are due to it encountering the gravity of the different moons and the planet. So given where the moons are, you can start calculating, okay, where is this thing? What is the gravitational force pulling on it? Where is it going to go? You can make very accurate predictions that way. People use that to figure out where all of the satellites around Earth are. There are complications that make this actually really specialized work. Like on Earth, you have to care about what the moon is doing. Where is the moon? It is perturbing things a little bit in certain cases. In this case, you have to care about what all these moons are doing. But you can calculate it and figure it out. And if you just basically say, okay, I'm going to apply a little bit of thrust here, you can turn an orbit like this into an orbit like this. It turns out you have to do something fairly wrong to crash into Jupiter. That takes a lot. That is not something that happens accidentally. It could happen, but it's not something like, oh, we got the thrust off a little bit. It would be like, we're going to decide. So it's quite likely at some point we may decide that this mission has to end, which would involve crashing it into, perhaps, one option would be crashing it into Jupiter. Can we do that? It's not even obvious you have enough thrust left to do that. So people do that. Basically, the reason we're pretty confident about it is a bunch of engineers who study this stuff has told us that won't happen.
How long do we think it's going to take to analyze all the data to find the answer to our primary objective?
That is an excellent question. And let me say so part of the reason I'm paid to work on this once the data gets there is so there is a group of scientists, which includes me, who are paid to look at these data. So all of the different things we're trying to do require different time scales. If, for example, it's like, is there a plume? Which would, basically say, yes, there's an ocean, we figured it, that would have a whole cascading thing. People will be looking for that as soon as that data comes in. Certain types of observations, like figuring out the depth and conductivity of the ocean, that happens at a specific time in the mission, because it needs to have the right combination of flybys. But again, it's a magnetic field signature, and there are people who are raring to look at those magnetic field signatures. In that case, it'll be like, okay, once we've done this flyby, and that data works, then we've got that particular answer. It's going to so most likely what's going to happen is each time we get a flyby, we're going to get more and more insights. Some of those things will be like, okay, this is what we thought, it's all converging. The fun ones are going to be, wait, what the heck is that? What does that mean? And that could have interesting implications. And the question, I won't say what those sequence of things will be, but that's going to be the entertaining story. Yep.
Has NASA looked at Europa from the James Webb to try and see the material?
It has. So the question is, has JWST looked at Europa? It has. Those data have, so the JWST data, it have observed Europa, and it has things that can see potentially water vapor. So we're all eagerly waiting for the people who have gotten that data to tell us what they saw. They haven't told us yet. So, but yes, we are still doing global scale observations to figure out what some of these materials are. But part of the issue is a lot of this stuff is very localized. And even with JWST, you can't resolve this. You can't see things this small. So all you see is a horrible mixture of all of this stuff, which makes it harder to figure out what's going on. So we're getting useful information. or we will be getting useful information once the people processing the data finish processing the data. But this is going to be, but yeah, it's not going to be able to answer all of them, probably.
If the test results determine that life could be supported on the planet, what would the next steps be?
Okay. So the next likely step would be a lander. And so just to say that so part of what this will be doing is if there is evidence that this could support life, and the chemistry of, so the one thing to say, everyone mostly agrees the fundamental chemistry of Europa and Enceladus are different, just because of their different sizes. Which one of those is better for life is something people are arguing massively about right now. If it turns out this is better, the next thing to do is land something there. That is its own complicated mission. This spacecraft cannot land. It is not designed to land. You guys have seen it. You can't even put it on the ground. It flops over. But the thing is, we don't know yet where to land. Part of what this will do, if we find evidence for that, is we could start to also say, where would you put a lander that could start looking at stuff in the near surface to figure out what's going on? If there is a vent somewhere, can we land near it? If there's not, can we land somewhere that at least seems to have the right things to make critters? That would be the next logical step after this. I think most people agree with that.
Is amongst the scientists, is there any consensus as to when we eventually might find life in the universe? And do you have any personal sense for that?
Let me say, I don't have a good sense for that. The way I would say is there's a couple different ways it can happen. I would say one of the most promising places for life, or detectable life, in our own solar system, one option is Mars. The other one, which I do think is probably a bit stronger, is in Enceladus, is like Enceladus, because we can access the water. The trick is doing that is really hard. So it would take a long time to get there. I think the other option is we see some sort of biosignature on an exoplanet doing spectroscopy. That is also very hard. People are, one of the things JWST is it could potentially do is see whether we see the right combination of molecules in an atmosphere that indicates there's life there. My expectation is that it's not going to be, my expectation is it's not going to be the kind of thing where we're going to have one press conference where there is an announcement that we have detected life somewhere and everyone agrees on it. I have a feeling it's going to be more gradual than that. Whereas, if it's on these, it's like, hey, we just found this weird chemical on Europa. It could be due to life. And it's like, wow, we just found this other chemical, which is also possibly due to life. Hey, we found these other 5 chemicals, and they're all consistent with this type of life. And I think, for exoplanets, it might be the same. It's like, we just found oxygen. That could be life. We found oxygen and methane. Now we're even more sure. There's a chance it will be the dramatic thing, but I have a feeling we're going to slide more gradually into it. That's at least my personal feeling now. I'm happy to be surprised at some point, but previous.
How long does it take the Clipper to send a signal back to Earth so we can begin interpreting that data?
A few, okay, I'm not going to remember the exact number, but it's a few hours. So just to say, the way this mission works, so it spends roughly a day in the data acquisition mode. Then each orbit it varies a bit, but it's weeks to months. So for each flyby, we get the data back within roughly a month for each flyby, and it will be and it takes an extra couple of hours. But again, part of the issue with the original idea of like push yourself into orbit around Europa, you can't downlink the data fast enough to do that because it is really far away. Your data downlink rate is really slow. So yeah, there's a little bit of time delay due to that, which can be really frustrating when you know the data's coming down and you can't see it yet. But it is of order, it's more the waiting for the spacecraft to deliver than the light travel time. Right.
So looking back at that orbital pattern, is there a reason why it appears to change directions partway through?
Yep. So, let's see. Yeah, so just to say, there is a very good reason. The sun is over here. So during this first part, it's mostly flying by outside Europa. But you want to be looking at the lit side. So you want to be on this, you want to have Europa, your encounters on this side of the planet, because then the side facing away from Jupiter is also the lit side. Later, towards the end of the mission, we want to look at the side facing Jupiter. But we also want that to be sunlit. So this whole movement stuff is to get into that configuration so that we can actually get both lit side on both sides of the planet, basically. And of course, sometimes we do want to look at the dark side. If we're looking for hot spots, night is good. So we actually have other kind of intermediate things happening in there, which gets back to the question of when will we learn the really cool stuff? If we need to wait to see the dark side, we need to wait till those orbits happen.
So how do we know that Europa is toxic to the spacecraft?
Because we've sent other spacecraft to Jupiter, the one who experienced this the most was the Galileo spacecraft, which orbited Jupiter in the 1990s, which I will now say I feel old because I think that's recent, and I know that's not true. That spacecraft, as it got further, more and more through its mission, basically it had more and more computer errors. Basically, every time it flew by a moon, something in the memory would break. Images would be failed to get taken because basically it wasn't a hard drive, but the equivalent of a hard drive getting partially corrupted. And that just got worse and worse over the course of the mission. Now, there is another mission currently here called Juno, which is also flying close but not through the radiation belts. And one of the big things about designing this was, how bad is it? And those various other spacecraft are part of what are informing that. And in fact, there is going to be some equipment on this to make sure just how bad is it, because that's going to be very important for a lander. Because the lander is going to be there. It can't get out of the radiation environment, or at least not as easily. Put it underground, it works.
You've indicated that it's a high radiation environment. Wouldn't that be just innately prohibitive to the existence of life, living organisms?
On the surface, definitely. That is another reason the surface is bad. But this type of radiation penetrates centimeters through ice. So, and in fact, going back to the question of what's the next step, one of the big questions is, how deep do you have, so if you're looking at the absolute surface, you see stuff that has been hit by lots of radiation. That could be informative, but might not be what you're wanting to sample if you're trying to do an actual life detection thing. One of the big questions they have, and part of what we're hoping to answer, how deep do you have to go? Because if you need to go down, a centimeter, that's easy. If you have to go down 10 centimeters, that's probably doable. If you need to go down a meter, probably you could do it, but it's harder. that's one of the things that would have to address. Yeah.
So does NASA? Okay, so I have two questions. The second question, if the first question is yes, does NASA want to send life to Europa?
It does not. So there's an entire group of people at NASA whose job it is to prevent us from contaminating Europa with Earth life. Because if we dump if we dump bacteria on the surface of Europa and that contaminates our attempts to find life, that's a bad thing. This is not a big issue for this particular mission because it's never going to land on Europa. And again, getting back to how do you know it's not going to crash into Europa? We're pretty sure. There's all these probabilities that those people have to deal with. If there is ever going to be a lander, it has to be sterilized before it gets to the surface. And there are all sorts of rules for which planets, which objects you can visit that you can do that. And you heard about Dragonfly. That is in a slightly different rule set than Europa is.
In one of the pictures you showed, there was water coming up to the surface because of the vacuum of space.
Yep.
Well, if it circles around and takes heat from Jupiter, then what if it freezes when it gets to the other side, which is why it doesn't happen so often?
Yep, that is exactly one of the things people wonder about. Because, as that water gets to the surface, part of it boils. That takes the high energy molecules out of it. What that tends to do is cause the other parts to freeze, which can block it back up. And let me say, there is a whole field of people who think about this stuff. And I think before Enceladus was discovered, most people would say, yeah, of course it's intermittent. It just freezes and does weird things. Remember, ice floats on water. It's not obvious how you get water going up through ice. It can happen, but it's hard. The thing is, on Enceladus, where we see water vapor coming out, it never shuts off. It just goes on and on for many years. Nobody knows how it's doing that, why it's not shutting down. Would Europa behave the same way? We have no idea. But the fact that Enceladus is doing something unexpected makes us worry that Europa might do something unexpected. But it is a reasonable question. Maybe it's just intermittent. In that case, what starts it? We do see it happen. If we see it happen, what lets this through? What conditions allow that? Are those predictable? People are looking into that.
If Europa is gaining thermal energy from Jupiter, why is it that the underneath the ice layer is impacting it, like the surface, more than Jupiter itself?
So there's a subtlety to that question. So remember how I said, these cracks, something is causing Europa's surface to get pulled apart. It is possible that the tidal stresses from Jupiter are part of that story. There are specific ones of these where, and is there a good example on this one? Let's see if I can find it quick. There's a specific set of those features, and let's see if I can find this one. Let's see, where is it? There. There are certain ones that look kind of periodic. They kind of they look like little hooks. People think that those might be cracks where basically as Europa gets squeezed each time, those cracks form an arc, and then it starts again. So the poles of Jupiter may be playing a role here. The question is, it's not completely patterned if it was just Jupiter. So it may also be that Jupiter plays a role, but there's other things going on deeper beneath the surface that's modulating it. For example, again, we think there's basically an entire rocky moon under here. What if that moon has mountains? What would that do to the flow of water and ice? We honestly don't know. It's one of the things we want to figure out. But yeah, it is completely possible that Jupiter plays an important role in getting these cracks going. And again, this is one of those things the experts spend a lot of time arguing about.
What if instead of crashing it into Jupiter, you could crash it into Europa with the camera on and see if there really is water under there and if it is ice?
So, two things. First of all, I mean, yes, that is an option. Well, actually, no, it's not, because we're not allowed. We're not allowed to, because that spacecraft wasn't cleaned well enough to be deposited on Europa. But the other thing is, most of the ice we think is very thick. Even crashing in the Europa Clipper at the kind of speeds it could do it, it would make a crater, but it wouldn't punch through. Even if you could find a place where we know the crust is really thin here, we could punch through. Great, you've punched through. You've also destroyed the spacecraft that could have looked at you punching through. So if the camera's on the spacecraft and it's now smashed to pieces. If we had another spacecraft that could see what was going on, that would be cool. We still wouldn't be allowed to do it, but that's not going to be the case in this particular situation.
Have scientists or NASA looked at inhabiting one of these planets with like farms of bacteria or tardigrades or something like that? See if life is possible.
So that is something that, so the question is, could we introduce life to see what would happen? NASA currently has no plans to do that, and that is actually there's an entire group of NASA called planetary protection. Because the idea would be doing that makes it basically impossible to figure out if there was life here to start with. So NASA very strongly says, no, you're never going to do that. If humans get to Mars, we've basically done that already. So when this reaches the level that, humans visit a world, then that's a discussion that can happen. For these worlds in the outer solar system, that's going to be a very long time from now. And so there is no plans currently along those lines.
Dr. Hedman, everybody.